first 45 minutes we have had, and I'm so tempted to ask John, not only do you have a green chemistry solution to recover the color of the hair, but can you also restate the growth of the hair? But that's something between John and me. My name is Achim Halpaap. As we just heard, I'm heading the Chemicals and Health branch at UN Environment. And for us, it's a real privilege to be part of this meeting today. When Sonja and Hannes outlined what would happen here in Berlin during this week, we really realized we are really on the same journey. We are approaching the same challenges from a different perspective. We're working globally, a bit more in the sky, but ultimately what we want is that the type of energy we're seeing here this week is happening all over the world, and we bring in developing countries into this journal. So I will today talk a little bit about the global context, the challenges and trends that we are facing, refer a little bit to some of these international agreements that Paul referred to already yesterday, outline a little bit the promise of sustainable chemistry at the global level, and also challenge you a little bit of engaging you personally or your institutions into work at the global level. I'm going to start my presentation by taking you 7,000 meters below the sea surface. And I don't know what that little creature is. Who of you knows it? Well, it's called an amphipod. And some researchers at Newcastle University looked at the concentration of PCBs in the tissue of amphipods 7,000 meters below the sea level. And what they found was astonishing. The level of PCB concentrations in these little creatures was 1,900 nanogram per gram of tissue. And that is comparable to 1 nanogram in coastal environments we find, or 100 nanograms in some of the most polluted rivers in China that we know. So it tells us really that the activities of man, or persons, mankind, are really affecting all parts of life, even deep down. And if you just look at this one chemical, PCBs, which is covered under a global agreement I'll mention in a moment, we are seeing still that significant unfinished business is done, and the mistakes of the past are still following us. So we have an estimated 4 million tons of PCBs still being all around the world, sitting in transformers, and the eliminated amount is really a small fraction, and 83%, despite a global agreement of the problem still exists. And this takes me to what we refer to as the University of Chemicals. I used to have numbers there, but we are trying to get the latest. But certainly on the bottom, we have almost tens of millions of chemicals invented, registered with a CAS number. We probably have, well, the old number was 140,000, but probably some less chemicals in commerce. And many of them are actually not hazardous. Many of them are and need to be managed properly, but not all are. But then when we move to the middle, that's when the potential problems start. Do all hazardous chemicals need to be replaced by green chemistry? That's the question I would have to John. We just had the problem, the blow up in the vicinity of Houston, where I think peroxides blew up. Was it a mismanagement problem, a land use problem, or do we need to replace organic peroxides by green chemistry? I don't have the solution, but there are many chemicals out there where the chemical industry also saying, well, we can manage them properly if we have the right regulatory and communication schemes in place. When we move to the top, we are getting into the chemicals of concerns, and that's really those subgroup of chemicals where internationally consensus is emerging that either we should be moving towards substitution, whether chemical or non-chemical, or on the top, and the chemicals regulated under the Montreal Protocol, really global ban phase out, because we know that certain type of CFCs, they really cause problems for the ozone layer, and we need to replace them. The problem is a little bit that most of the attention globally we have put on the top level. So we have focused on a few chemicals through globally legally binding agreements, and we have not done, I think, a proper job yet to cover, the bottom of the pyramid. A few trends, I think, that show also what magnitude of the challenge we are facing. So the world economy and the global market for chemicals is likely to quadruple by 2050. As John said, a lot of money is to be made, but it needs to be the right money compatible with sustainable criteria. Secondly, I would like to outline that growth is fueled by rising middle class, urbanization and mobility in transport. So we know the sectors which are fueling the growth, or which are growing and fueling the growth in the chemical industry. So understanding them better, I think, helps us also to focus our innovation and research efforts. And then we are seeing fundamental structural changes in the chemical industry. All these recent takeovers you have seen, Bayer taking over Monsanto, ChemChina taking over Syngenta, lots of changes. So what does it do to our sustainability objectives? Are we seeing a race to the top when these mergers occur, or a race to the bottom? Very fundamental questions I think we need to be aware of. And then the last point I want to highlight is, while we are seeing now that the production and consumption of chemicals is moving around the world, and you may know that China is now the largest producer and consumer of chemicals since a few years. So these production patterns have moved around the world. The regulatory system and the management capacity have not moved with equal speed. So this is something we need to address globally also. So what's the toolbox that we have available internationally to address some of these challenges? Here are some of the global multilateral environmental agreements that you may have heard yesterday that are trying to tackle, transparting with the most famous one, the Montreal Protocol, moving on to a convention called Basel Convention that deals with the transboundary movement of hazardous waste. We have a convention that was signed in Rotterdam in 1998 that deals with chemicals which have been banned in some countries but are still sometimes exported because other countries are wishing still to use them. And then, of course, the very famous Stockholm Convention dealing with persistent organic pollutants, which has covered a few what we refer to as dead chemicals, like GDCh, which is only used perhaps in 2 or 3 countries, but it's moving slowly into chemicals where you still see major markets like flame retardants, in the car industry are now starting to be regulated in the Stockholm Convention. So these instruments moving into areas which become a substantial commercial topic too. And then the Minamata Convention on Mercury, again, a single chemical approach to one agreement, where very soon we will be celebrating the convention coming into force this year in Geneva. But we're also learning a little bit what has worked internationally, what has not worked internationally, what's the unfinished business. So these global agreements are very time and resource intensive. We take a chemical by chemical approach. Often we sometimes see that substitution initiatives are not necessarily replacing the problem. So you're fixing an ozone problem, but you're creating, a market of chemicals that are causing global climate change. We have seen this, right, with the HFCs and some of the replacement. So while sustainability with the smallest is achieved, it's not achieved, with a capital S, as also John alluded to. So we need to really also then link our work to the broader sustainability questions. Just for your background, we do have actually a goal to achieve the sound management of chemicals, and that was adopted by heads of state in Johannesburg in 2002. By that time, 2020 seemed to be very far away, but we're getting very close, and we are learning that this goal adopted in 2002 is not being met. So we have to figure out what to do next, and I will talk a little bit about it in a moment. Now, governments and stakeholders have also understood that these MEAs, while doing a good job in some cases, also have limitations, and therefore in 2006, the strategic approach to international chemicals management was adopted with a major meeting taking place in Dubai, the first international conference on chemical management. And SciChem is different than these MEAs because they do not only, SciChem does not only give a voice to governments that are the key driver in regulations and setting goals and standards, also industry and NGOs are a full member around the table. So they're not sitting in the back and speak last, they're really able. So this has advantages and disadvantages, so everybody is engaged, but also the more people you bring around, right? You are not always moving to the highest common denominator. But SciChem exists, and we need to figure out how to make it work more effectively to address some of the challenges that are outlined. Here's just an example of some of the constraints or challenges we are facing. You may have heard about a global system to classify chemicals. It's called the Globally Harmonized System for the Classification and Labeling of Chemicals, in short, GHS. It took the world 10 years to harmonize classification criteria, what constitutes a hazard, so that a chemical that's very toxic in Australia would not be safe in Massachusetts. So the governments recognize hazards affect everybody equally. That system was adopted in 2002. We are now in 2016-17, and you can see that the great majority of countries do not have implemented that basic system for communicating hazards to workers and the public. So the bottlenecks are really significant. But we have also opportunities, and you have heard about the adoption of the Sustainable Development Goals in 2015 at the General Assembly. Yesterday you did a roll call, Paul, and not everybody here in the room necessarily was familiar with the SDGs, which is very interesting. So those working on it think, okay, we have something in place now that guides governments, industry, NGOs around the world for really shaping development in a different way. But when we do polls in our meetings, we see that only 15% maybe have heard about it. So again, who has heard about the Sustainable Development Goals? Well, a few more, but actually, yeah, Paul talked about it yesterday, right? So this but nevertheless, why are they so important? First of all, they bring together all existing international policy initiatives under one framework. So it's not anymore a climate change agreement and a chemicals agreement and a trade agreement. It's all being addressed in an integrative way. And there's one principle underlying all of this work. Sustainability, it's not either economics, environment and social benefits, it is economic, social and environmental benefits. So it creates a benchmark for analysis, and I think that goes a little bit into also the direction you outlined. So every activity needs to be screened now against 3 criteria, and if one criteria is not met, we do not have a contribution to sustainable development. And that's universally adopted now and creates a very powerful framework. Here are the goals, 17 of them, and under goal 12, sustainable consumption and production, we do have a very specific target, again achieving the sound management of chemicals by 2020. That's one of the few targets that was not adopted with the 2030 framework. But we also see that many other goals, for example, zero hunger, of course, are dependent on the sound management of chemicals and green chemistry and sustainable chemistry. So in that sense, chemicals cut across all these development goals. And if we analyze the goals, then we see that we have the targets directly referring to chemicals waste management, but then we also have these other targets, such as the zero hunger target, where we're saying, okay, we need to ensure that chemicals management is an integral part of the discussions to implement that goal. And here's just an example. I took those pictures on the top, actually close to our home in France, where a new shop opened, Le Grand Freie it was called, and we got all excited. We thought it was a farmer's market with fresh products, you know, where the farmers come in. The first thing I saw was lots of food packaged in plastic wraps, okay? And the argument was, okay, we use plastic wraps to keep our food fresh. Now, can you beat that argument? Very difficult, right? But we also know what happens to the plastic wraps. In fact, we don't even fully know what chemicals are used in the plastic wraps, you know, to make them flexible and endurable and so on. And we have the waste problem. So you're facing a challenge under the SDGs, right? You can say, yeah, plastic wrap will achieve the goal, zero hunger, because food stays fresh longer and we avoid many diseases and you know, infections, and that argument is valid. But at the same time, the other side of the coin is that meeting all the 3 criteria of the SDGs, no, it doesn't, because we know what happens to the plastic, and that's where also sustainable chemistry comes in with solutions. So, what's the promise then, internationally, of sustainable chemistry? Oh my God, this is a long slide, but this is the text that was adopted by Ministers of Environment in 2016 at the United Nations Environment Assembly. And that assembly is guiding the work of our organization. These are 190 ministers coming together every 2 years, next time in December, and they are setting global policy. And as Paul mentioned, for the first time, they mentioned sustainable chemistry as an opportunity. And they've requested the UN Environment Program, or UN Environment, how we call ourselves now, to work with all of you to collect best practices, do an analysis. And John, I'm going to ask for your slide set because you had some very good ideas also how we can frame perhaps sustainable chemistry globally and how green chemistry can contribute to this. The potential I see, or we see, it is a narrative that is fully compatible with the sustainable development agenda that I just outlined. So the term is gaining currency, although not everybody has learned about the SDGs. Secondly, it's a positive story. It's a story of transformation. It's not about banning chemicals. It's about finding the solutions to accelerate from brown to green chemicals, or from the bad to the good, or whatever we want to call it. It advances a chemistry that is compatible with all the three dimensions of sustainable development: environmental, social, economic. It is a potential driver to help detoxify chemical products and production processes through alternatives. And it helps, I think, also to shake us a bit. Those having worked on chemical management for 10, 20, 30 years, we have been obsessed with hazard assessment and risk management and writing 300-page reports about individual chemicals. And sustainable chemistry takes us out of that paradigm. I think we should not give up on it. We still need good hazard and risk management, but there is something else going on and new topics are emerging. So what are they? Research and innovation, innovative business models, looking at economic incentives, policies, technology transfer, curricula, greening, topics which the chemical, I call it, us the chemical geeks, have not looked at. And we need to now figure out what can we do in those sectors in order to achieve the fundamental objectives we are all committed to. So who helps us with this? What are the drivers out there that help to create momentum? So one example is media coverage and the new information society. We have now lots of journals having actually scientific writers who know about science and about toxicology, and they're also participating in the journey. So some of these newspapers are actually very interesting for us in the sense of finding out what's going on around the world. So we have a media that is much more interested than in the past. And we're having champions. Now this is Chuck Schumer. I don't know if you know him. He's the majority leader in the House of Representatives in the United States. And he personally got engaged when a report on toxic chemicals and heavy metals in makeup for kids was released. So, you got, politicians interested in this because we're all human beings, many of us have children, it touches us, and there's a whole new, I'd say, governance of chemical management evolving, which I think we have to be aware of. The retailers are getting active. I'm not going to go into details, but they are replacing their products saying, we don't want to wait for regulation, we just don't want that bisphenol A is in baby bottles and there are alternatives out there. So that takes me to the last few points here. What are the opportunities for all of us to work together and to engage? Firstly, UN Environment in the area of sustainable chemistry, we are doing a report by next March. And the deadline that the government set was 30 June this year for all of you to submit best practices. We give all of us and you more time. So we will open the web page and you can submit good practices. And the final deadline will be 15 November, and we're happy to send a communication around. So if you have not participated, please do so. We'll give you the possibility, and that will inform our report on sustainable chemistry that we have to commission next March. Secondly, tomorrow we took the advantage of so many of you being here to bring in some international participants and discuss a little bit more specific startup companies and the lessons learned. and then drawing these insights from the participants and channeling them into global publications on this topic. So tomorrow is an opportunity for some of you to engage. But also, last point I want to make, human environment. So we are also thinking through what in addition can we do to the report, to the workshop tomorrow. In the area of energy, we do have a collaboration with Frankfurt University. It's called a Seed Capital Assistance Facility. It helps startup companies engaged in renewable energy to get initial consultative support, because engineers are not necessarily trained in business models. So there is some initial support that has been provided for renewable energy. Is that a model we can take to sustainable chemistry? It's a question that we will discuss tomorrow. We have the Global Chemicals Outlook upcoming, a flagship publication that guides decision-making on the future of chemical management, and we will use the knowledge generated here also to inform this. The ministers again, and that's my last slide, will meet very soon in December, and there is an opportunity to also participate with your commitments in contributing to the theme of this assembly called Towards a Pollution-Free Environment. So there is a website, and you can see that individuals have been challenged to also make commitments, and there are 1,003 commitments already made. You can personally participate and indicate what your commitment is, and the numbers are growing. But since yesterday also, the website is open for commitments of government, business, and civil society. So if you have something to contribute, please, as a commitment, please participate in this, and this will be showcased then in Nairobi in the beginning of December. Last slide. Under SciChem, we do have a process to develop a chemicals and waste policy beyond 2020. There is a process now culminating with the 5th conference in 2020, and next year are a series of critical meetings. So if you're interested to see how you can participate in shaping the national position, stakeholder position, then please get engaged. So with this, I would like to conclude. There is more to be said on this topic this afternoon. We have an informal session at 3:30. Jost, which room? Those of you? 105. 105. Oh, okay. With this, thank you very much. Great to be here.